Okay, here's a new transformation. So let's look at what it's saying. So this transformation is going from P2 to P2. So this means polynomials of degree 2 to polynomials of degree 2. So let's look at what the transformation says. So it says if we take polynomials that look like this, I get this out. Let's think about this a second. If I take something like this and I get this out, does this look like, no, could it be the derivative? The derivative of a constant is 0. The derivative of a1t would be a1. And the derivative of a2t squared would be 2. Carry the a2 along, t to the 1 power. So this is the derivative, right? Okay. So let's play with this. So it's saying it's going to P2 to P2. It could say P2 to P1, right? We know that the derivative decreases the power, but they're just letting the codomain be as big as they want it to be. Okay, so they're giving the codomain and the domain the same basis, which is this. So I need to do the transformation on each of the domain basis vectors and then write them in terms of those basis vectors, right? Okay, so let's just do the transformations just because we know what we know, right? So because I know what the derivative does, so I know that the derivative of 1 is going to give me 0, right? If I know that the derivative of t should give me 1, and I know the derivative of t squared should give me 2t, right? That's me doing the derivative on each of the 3 domain basis vectors. Okay, so let's just make sure that I can see that as I'm putting it together with this a1, a2, right? Because I've got to make up the column vector for these things. So the derivative of 1, right? So here, actually, let me just take time. So I really want to write my basis vector 1 in terms of a0 plus a1t plus a2t squared, right? So I want 1 to equal this. So I can see, sorry, I'm starting off with the 1, so I know that a0 is 1, a1 is 0, a2 is 0, right? Okay, so when I'm taking the transformation on the 1, right, taking the transformation on the 1, doing what it says, the answer by plugging in the a1 and the a2 is 0. Okay, so this 0 I have to write as a column vector, right, in terms of the 1, the t, and the t squared, right? So this has to be the coefficient of the, or the constant. This has to be the coefficient of the t, and this has to be the coefficient of the t squared. So each of them are 0. So it not just gives me 0, but it gives me zeros in terms of the basis vectors for the codomain, which is this. All right, so let's do that same thing for t. Okay, so I want to write t in terms of a0 plus a1t plus a2t squared, right? So this means a0 is 0, a1 is 1, a2 is 0, right? So in order to write it like this. So to do the transformation, to do this, I get 1, right? And then 0 for the times the t. So it just gives me 1. Again, I want to write this as the column vector. There's the constant terms. Here's the coefficient of the t's. Here's the coefficient of the t squareds. So I'd have 1, 0, 0. Last one. Okay, so I know the derivative is 2t, but again, let's just take this domain vector and write it as, okay, so I can see a0 is 0, a1 is 0, a2 is 1, right? Comparing these. Okay, so using these 3 things in here, right, in case it's not the derivative and I have to figure out a little formula, a1 is 0 and a2 is 1, so I would have 2 times t, and that's what I have right here, 2 times t, right? By plugging in a1, a2 is 1. All right, so now I need to write this as a basis vector, in terms of the basis vector for the codomain. So I'm going to have a 0 constant term, a 2 in front of the t, and a 0 in front of the t squared. Okay, so this says find the matrix. So they're calling it the beta matrix because there's only one basis, or a set of basis vectors. So the matrix for the transformation, matrix for t, or we can call it M, which is called the matrix for the transformation, is 0, 0, 0, 1, 0, 0, 0, 2, 0. Okay, so let's go find the image of this. Okay, so let's think about this. We could do this two different ways. I know that this transformation of P says find the derivative. So let's go find the derivative. The derivative would be 3 minus 2t. Another way to find what the transformation does would be to multiply the matrix of the transformation times P written as a column vector. So that would be 2, 3, negative 1. So let's check it out. Does it give us the same answer? So let's do some matrix multiplication. 0 times 2, and I'd get a 3 and a 0. So 3 would be in the first entry. So second row, I'd get 0 times 2, 0 times 3, negative 1 times 2, so that gives me a negative 2, and then I get a 0. Oh my goodness, look at this. Doesn't this translate to 3 minus 2t, which is the same thing I got? Nice. Okay, so here's a little bit of a different one. Here they're telling us this is the basis for V, and then R2 we know is has a basis of 1, 0, and 0, 1, right? The standard basis. Oh, here they say standard basis for R2, which would be 1, 0, 0, 1. So they're telling me the matrix, almost. They're telling me what happens when I have x1, x2, x3 times my basis vectors. It gives me this. So can I break up a matrix? Can I break up the numbers that give me this as the matrix if I'm multiplying the basis vectors times x1, x2, x3? Can we do it? So it looks like I can see I've got to have 3 columns, right? Because each of the 3 basis vectors. So can we figure it out? I think it's 2, 0, negative 4, negative 1, 5, 3. Because if I multiplied 2 times x1 minus 4 times x2 plus 5 times x3, I get that row. And if I multiply 0 times x1, negative 1 times x2, 3 times x3, I get this row. So this is the matrix for the transformation. So the matrix for the transformation is this. So this was just kind of a picking it apart. They gave you a lot of things.